I don't care if you write next week. I frankly don't care, Max, if we don't write a test all year. And at the end of January, I give you 8 unit tests. All in the last 2 days. The last 8 days. I could give you, there's 1, 2, 3, 4, 5, 6, 7, 8, or 7 units. So the last 7 days of class, I can give you 7 unit tests in a row. And then in the 8th, I'll give you a final. We write no tests till then. You want me to do that? It doesn't matter to me. I couldn't care less. What? Apparently the test is Wednesday, Jaskira, because there are people in the class that feel this is a democracy. And at some point or another, I said in passing Wednesday, which of course makes it law. I say a lot of things in this class you guys don't give a rat's ass about. Do this homework tonight. My third cousin's goldfish had babies, so I had to be at her side just in case one of the babies didn't make it. Oh, okay. Yeah, so I couldn't do my homework. All right. But I say once that maybe the test might be Wednesday because I might forget to print it, and all of a sudden that's law. When's the test? Oh, you're writing your test Tuesday. What? You said Wednesday! But fair enough, the test can be Wednesday. Because again, I don't care. Of course, you are well aware that that means today and tomorrow we will be working on new stuff. And the way your people's brain seem to work is it fills up with radicals and it's chock full. There's a little square root symbol falling out this year, and there's a little index falling out this year. And then today when we start factoring and I start cramming factoring into your head, the radical stuff will just ooze out a little bit. But that's fine. That's fine. We'll have the tests on Wednesday. First block. And then of course, at the end of the year, I will keep track of the tests you wrote in first block and the tests you wrote in second block. And I will show you guys, statistically speaking, why you shouldn't write your tests in first block. But no problem. I'll give it to you Wednesday. Because I care. Now, the first thing whoa, that was interesting. It appeared, then it disappeared, then it reappeared, and the computer never froze. Is it still on the screen behind me? We are off and running on this Wednesday morning. See, now I'm stuck with Wednesday on the brain. That's all I can say is Wednesday. It's funny, but it's not that funny. I know, Yoon, it's funny. All right. The first thing you have to I like to think that teachers in other countries of the world aren't clowns like me. I like to think that the international students are getting not only the benefit of coming to Canada, but they get a good show. It's a long trip, right? So I like to make sure, because some of these international kids are only going to be here for 10 months, and they're only going to be in my class for 4, right? And that's just, how can you not want more of this? Am I right, Sarah? Damn right I am. Look, you're back for a second year. Yeah. All right. You're back for a second year. You're back for a second year. You're back for a second year. You're back for a second. Sophie took a year off and missed it so much she's back after a year. So there. Right, Yoon? Yeah, brother. All right. First thing you got to be able to do is you got to be able to simplify. Simplify, and you got to be able to return. What do I mean by that? You got to be able to take a number like not the square root of 98, and you got to be able to recognize that's 49 times 2, and you got to be able to recognize that that is 7 root 2. But then you got to be able to bring it back to recognize that that 7 goes back under there and becomes 7 squared times 2, so you can get back to root 98. Does everybody understand? Got to be able to go both directions out of a radical, okay, depending on the situation. Yeah? Yeah. Excellent. Second thing you got to be able to do is remember you got to be able to add and subtract radicals. What are the keys to remembering what you can add and subtract? What are you allowed to add and subtract? Same. Radicand. Yeah. It's got to be the same index and the same radicand. If you do not remember what those words mean, I would suggest looking them up. No, I'm just kidding. Of course, I'm going to show you right now. I'm going to change that to 18 because 8 has a cube root. What would that answer be? Okay, this isn't a trick question, guys. You're writing a test on this on Wednesday. What would that answer be? 4 cube root 18. You're adding. I got 1 cube root 18 there, and I got 3 more cube root 18s there. Okay? Would we leave it like that? Is that the final answer? Yes. 18 doesn't cube root anymore. It's 9 times 2. There's no cube roots in there. Okay? Yeah? Yeah. All right. What if I had this one? That's not an index. That's a coefficient. Can you add that?
No.
Really?
Not right now.
Not right now, because you have to do what? Simplify, the first step. What's 3 root 8? So what is it? 6 root 2. What's 18? 9 times 2. So what is it? 15 root 2. What's 50? Yeah, 25 times 2. So what is it really? 15 root 2. So what's the answer really? 36 root 2. Everybody Gouda? What if I tacked on there a root 27? What would that be?
It's 3 root 8 instead of root 3.
Yeah, it's 3 root 8. I said that was a coefficient, not an index. What if I tacked on a root 27 here? What would that be? 3 root 3, right? Could I add that in here? So what would the answer be? Plus 3 root 3. Can everybody add? We all know that subtracting's the same thing, right? You don't need to see an example of subtraction, do you? Okay. 3, you must be able to multiply. You must be able to multiply in 2 ways. You must be able to multiply a monomial. Oh, there it goes. Now it's freezing. By a monomial. Which is, of course, cube root 7 times cube root 4. What would that be? Cube root 28. Would you leave it like that?
Yeah, you would.
Can't cube root 28. What is the key to remembering? Same thing as adding. Not quite the same thing as adding. Just like in fractions. You only need the same index. Okay? Now, there's a couple of tricks in monomial. What is the square root of x times the square root of x? What is the cubed root of x times the cubed root of x? Cube root x squared. What is the cube root of x times the cube root of x squared? X. Everybody understands that, yes? Yes, yes? Oui, oui? Très bien. Or muy bueno. Or if you're Brazilian, whatever that would be in Portuguese, because I can't speak any Portuguese. Not a word. Although I should learn some, because more and more of you guys are coming from Brazil. I should learn me some Portuguese. Time to learn my 5 sentences in Portuguese. You guys all know my rule for foreign languages, yes? 5 phrases in every foreign language, everywhere you might visit. Where's the bathroom? Everyone should know that phrase. Where's the bathroom? You should all know the phrase, where's the blank? Blank being the tourist attraction where you are going. So when I go to Mexico, I know where's the beach. Right? You should always know that. 3, where's the whatever the local concoction is that people like to drink? Where's the pina coladas? Where's the beer? Where's the 3? 4, hello, my name is blah. Okay? Me llamo Mateo. Spanish, kind of. 5, I don't speak your language. Do you speak English? You know those 5 things, you're fine. You'll be set to go. Actually, there's a 6th I like to know, but that one's private. All right, everybody can do monomial. What if it was this? Root 75 times root 28. What would you do? Simplify first. Why? Because 75 and 28 are giant numbers, yes? All right, now, next thing. I'm going to give you a little shortcut here that I never actually taught you, but I did in my notes a few times. See if anybody will pick it up. This is 25 times 3, yeah? This is 4 times 7, yeah? Right? So this whole thing is the root of 25 times 4 times 3 times 7, yeah? Put it all together. What's that root? 5. What's that root? 2. What's left under there? 21. So it's 10 root 21. Everyone see? I've done that in my notes a lot, especially with big numbers, right? Everybody can divide monomial. Everyone can multiply monomial. Going once, going twice, going thrice. What if I had this? Root 12 times cube root 16. Can I multiply that? I know. See you. Make sure you watch the video. Bye. Can I multiply that? What should I do? Simplify. So what's that? 2 root 3 times, what's that? 2 cube root 2. Excellent. Can I do one more thing there? I can leave it that way, but there's one more thing I could do if I really wanted to. Does anybody remember what it is? I made you do it on one question. Kind of. You would still do 2 times 2 to get 4, and then it would be cube root 2 root 3, all in one line, which is going to show up in a second. But first it's going to not respond. Then it's going to respond. Everybody Gouda? All right. And the other thing you need to be able to multiply is polynomial. Well, no, we won't do polys. We'll only do binomial. By binomial. Actually, I don't even want to say that because it might be binomial monomial. So I'm going to actually erase that. You must be able to distribute. So if I had root 7 plus root 18 times root 8 plus root 20. You need to be able to do that, which is, of course, just FOIL. That. But what would you do before you did any multiplying? Simplify, because this might disappear, right? You might be able to add that, and then you don't have to FOIL. Everybody understand? Okay. Do I need to do that one, or are we good? Why don't you guys do that one? I'll just have a sip of coffee and relax for a moment. Okay, you guys go ahead and work that out while I relax for a moment. Oh, that's the stuff. Stay in school, kids, and you too one day can have the leany back chair. Played some hockey last night, Max. No. I grabbed my helmet, my goalie mask, and the snap was missing on the strap. I don't know why. I was like, you guys almost never hit me in the face. It'll be fine for today. I got hit in the face a lot last night. I do indeed. It's not easy. And we're the last team on the ice, so they let us play forever. But if you're a skater, you can just leave when you're tired. But if the goalie leaves when he's tired, kind of wrecks the game for everybody else. But on the plus side, nobody hit me in the junk on Sunday. So this is, of course, really 2 root 2. This is, of course, really 3 root 2. And this is, of course, really 2 root 5. 2 root 5. 2 root 5. 2 root 5. There it is. And then, of course, you would FOIL it out to get 2 root 14 plus 2 root 35 plus 6 times 2, which is 12, plus 6, slide over, 6 root 10. It won't let me slide over. Right? Everybody can distribute? Awesome, possums. Now, that should be getting close to the bottom of your guys' page. Did I give you a second page for this one? I didn't? It's kind of a... Wow. Because you also got to be able to divide. What's the key to dividing? Simplify always. How do we divide? Same way we multiply. Coefficients divide, radicands divide. I don't even want to talk about division, do I? But there is one thing you got to remember on division. What's that? What are we up to? We're up to number 4. I got to remember to rationalize. So is this okay? No. Is this okay? Ahem. Oh, that's a new one. It stopped halfway through. Quality. That's okay, though. Okay. Is this okay? Is that okay? Is this okay? Still not okay, but better. Why? Because I took care of 6 and 2, the coefficient. Okay? What makes this better? What should you do first? Simplify. So that's 9 root 3 over 3 root 2. Yes? Is that better? Still better. Is it done? What do I do next? What do I do with 9 and 3? Divide. So what do I get? 3 root 3 over what? Root 2. Am I at the end yet? What's my last step? Rationalize the denominator, which means multiplying by what? Root 2 over root 2 to get 3 root 6 over 2. Everybody cool? That's every step. Everybody's got it? What do you have to remember about one that looks like this? How would I rationalize that? Because I can't divide. Oh, wait, 12's a bad one. Stop it. Don't use 12. No, I can't use that one either. No, that one I can use. If you were going to rationalize that, what would you do? What would you personally do with that green question? You would simplify first. Okay, so what would it be, Jez Carrot? Pardon me? So it would be 10 and 2. Really? I would use 4 and 5. But it doesn't matter. And then 10 would break down into 5 and 2. So there's your pair, yes? So what comes out? So it's 10 root 5 over what? That is... Oh, you actually... Okay. So this one you broke down slowly, and this one you broke down all in one step. Okay, just making sure. 18 root 3. Then what? What would you do now? You would rationalize. Okay, now here's what I'm talking about. What's the only thing you have to use to rationalize here? Just the root 5. Then you get 18 root 15 over what? 10 times 5. Which would be 18 root 15 over 50. Then you would simplify 9 root 15 over 25. Yeah? Okay. What if my denominator is a binomial? Pardon me? I have to rationalize. No, still just the denominator, but how? What do I have to multiply by? Starts with a C, ends with an E, has conjuga in the middle of it. The conjugate. Root 6 minus 2 over root 6 minus 2. Right? And you all know that would be 3 root 42 minus 6 root 7 over, what's the bottom going to be? 6 minus 4. 3 root 42 minus 6 root 7 over 2. Yeah? Yeah. Everybody good? Okay. What if it was the exact same question, but it was 2 root 6. What would I have to remember in this case that I didn't have to do in the green case? If this was 2 root 6, what would I have to remember that I did not have to do in the green case? I got to include the coefficient. Okay? Everybody good? Everyone's ready for their tests on this? On Wednesday? Tell you what, you guys are going to have your tests on a day that ends in Y. See what I did there, Sarav? Huh? All right, everyone's good then, yes? Sweet. Test tomorrow, Wednesday. Turn over your page to page 50. You should not need my help with this. There are 14 polynomial multiplication questions there. Go. This should take you about 7 minutes at the longest. 30 seconds a question. My computer is frozen. See if you can beat me, because I got to sit here for a while. Frozen again. More time for you to catch up. You can check your work over up to J on the screen right now. Make sure you are able to distribute effectively. Since you just did this with radicals, and it's actually harder with radicals, And there's the last 4. Can everybody distribute? Remember, this here, if you've been in my class before, is just something I have shown students who have trouble distributing effectively. You do not need to do that. Everyone got 14 out of 14 on distribution. Or close to, yes? I will wait a moment while you make sure. Okay. May I go on? Pardon me? 10n. Well, if you look closely at n, you see that it is exactly the same as k, right? Because it is the same factor there, and then you are subtracting and adding the other one. So if k was x squared minus 64, what if there was no y here? Then what would it be? X squared minus 1, right? Okay. What if there was no... What if there was no x there? What would it be? Y squared minus 1. So, since you know how to do those two, you know how to do this. Everybody good? Cool. What? E as in excellent. Oh, good God, it's not minus 36. I did 3 times 12. It's 108. Woo! Look, I'm going to write it in big, thick red to remind the world that I did 3 times 12, not 8 times 12. What an idiot. 9 times 12. Still an idiot. Woo! That being said, I did just impress everybody with my quick knowledge of the 12 times table. I hope. After I disappointed you all by multiplying 3 times 12. Of course, you all know the mistake I made was as I saw that 3 and I multiplied it there. Which is, of course, a dunderheaded mistake. A mistake of which we are all guilty in this room of at least committing once or twice per quiz or test, yes? What causes those mistakes, Sarav? Is it not being able to multiply? Or is it rushing through your work? It is rushing through your work. Do not be Russian. Be Canadian. See what I did there? Russian. Russin. Of course, if any of you are Russian, feel free to continue to be Russian. But don't rush your math. Just like if you're from Italy, you shouldn't be Roman. You should stay in class. Roaming. That one wasn't as good, Yoon? Oh, that hurts. All right. Okay. Quick review of factoring, even though you do not, any of you, need this review until we get to the 4th kind of factoring. But I'm going to do this review anyway. First type of factoring is the greatest common factor. Please remember, this is he waited patiently for his technology to catch up. Excellent. This is what you should look for first. Always try to do this. Now, some of you have trouble remembering how to factor stuff. And it's partly because you've been taught steps to do math all the way along. I only have 4 months with you. I cannot break you of that habit. So first thing I'm going to do is tell you what factoring is. It is the reverse of distribution. It is the inverse operation of distribution. Just like the inverse operation of addition is subtraction. Okay? That is what is actually happening. So, if you can do distribution, you can do factoring. But that's not usually enough. You guys need steps. So here are the steps. To greatest common factor, you do three steps. 1, you decide on getting a new computer that actually works. You decide on the GCF of all terms. And when I say all, I mean 3 things. All the terms in the polynomial, the GCF of all the coefficients, and the GCF of all the variables. Right? Step 2, you divide all terms by the GCF. Again, I am highlighting all terms. And step 3, you write your answer as this: GCF bracket quotient oh, this is a long one. Quotient 1 plus or minus quotient 2, and so on. Everybody remembers how to do this? What is the GCF of 6x and 3? Step 1, the GCF is 3. Step 2, divide everything by 3. Divide by 3, divide by 3. Step 3, write the answer. The answer is the GCF, then brackets. What's the first quotient? 2x. What's the second quotient? 1. Come over here. What's the GCF? 2x. So I divide everything by 2x. Then I write it out as 2x with what answer? 2x plus 3. Remembering, I need to know my exponent laws from the very first review unit. Is everybody good with GCFing? You should be, but you'll notice I left a big white space. Why do I leave big white space? So I can write a really difficult one and see if you can figure it out. Go. What's that one? What? What's the GCF? It is 3a squared b4. And how should I write this? I like to write this with the positives first. 6. A squared b. A squareds are gone. What's b? B, then what? C minus what? 1. Almost everybody forgets to leave the 1 there. Did anybody forget to leave the 1 there? Good. That makes your math teacher very happy. So happy that, well, he's just happy. All right. Trinomial. Again, it is the reverse of distribution. A great many of you need to see the steps here. Again, it's easy for me to show you those steps, so I will. You know that to get a trinomial, you've got to have something squared, and you've got to have some other term. And they can't be the same, or that middle term might drop out. So if you're going to reverse this, the easiest way to do it, if you don't actually understand what's happening, is to remember this. That's A, that's B, that's C. You need 2 factors of C that add to B. Right? So what are the factors of 7 that add to 8? 7 and 1. So since that's positive and that's negative, it must be x minus 7, x minus 1. Right? If you are ever in doubt, is it easy to check? Of course. You simply check. Is negative 7 minus 1 negative 8? Yes. Is negative 7 times negative 1 positive 7? Yes. So you're right. What should I do here first? You GCF first, because you should always try GCF first. What is it? 3. So 3 comes out there, and what stays in? Excellent. Now, what did that give me? A trinomial with no leading coefficient, right? Which I just factored here. So what do? I need to multiply to what? I need to multiply to what? Negative 8. And add to what? Positive 6. What is it? What is it? Is it? Is it? Again, the danger of learning steps. Is it 4 and 2? No. Why not? 4 and 2 makes 6. 4 times 2 makes 8. So why isn't it? Because the 8 is negative. Is this factorable? No. How many of you would spend 10 minutes trying to make 4 and 2 work? All of you put your hands up. Why did I put this question at this juncture? Because it is just as important to know when you are done. A great many of you, because you memorize steps, get locked into making sure you try to complete those steps, even when you can't. Understand? Yeah, all right. Now, as always, there's blanks there. Why are there blanks there? Because I want to give you some slightly more difficult ones. What would this be? No. Sorry, not 30, not 30. How do I get a minus there but a plus there? What do I need to multiply to? What do I need to multiply to? Negative 39. What do I need to add to? 10. What is it?
13x.
X plus
13x.
13 and x minus 3. Why is that slightly more difficult? Because I've gone past the 12 times table, which is what a great many of you stopped memorizing your times tables at, if indeed you have memorized your times tables at all. Pardon me, Akshay? You have your times tables memorized? Really? So I can say any two numbers from 2 to 12, and you will have an answer for me without doing this, looking up to think or counting on your fingers, for the most part. So we've gone from yes, yes to mostly. So should we try a few? Okay. 8 times 4. Never mind. You're rusty. Okay. Stretch a little. Warm up. Yep. Get ready. A couple of jumping jacks. You sure? You ready now? Yeah? Okay. I'll even let you choose the first number. You choose a number. Okay? 1 times 12. Excellent. I'll let you try a second one. Go. Choose a number. 2 times 12. Excellent. I'll let you try a third number. 6 times 7. Oh! I do got to let you get there because your thought moves at the speed of light. So 6 times 7 at the speed of light should already be out of your mouth by the time I finish the n of 7, right? If it's memorized. I'm not trying to put you down. I'm not being a dink here. I am just trying to prove to you guys that what you think is memorized isn't really memorized. And if you want to do anything, if you want to do the number one thing to make math easier in any grade level, including university, it's memorize your times tables. So when I ask you this, 425 times 8, you can do that quickly. Yes, it's 3,200 plus 200 is 3,400.
What's 972 times 4?
972 times 4. That's 3,600, and 280 is 3,880, and 14 is 3,894. Yes, of course I had to think about it. I have not memorized my 972 times table. But Max, the point I'm trying to make is I got that answer faster than a bunch of you could punch it into your calculator. And again, I am not showing off. I'm just saying, if your RAM, right? If your RAM isn't taken up trying to remember what 9 times 7 is, then you have access to that part of your brain to actually work on the complicated part of the question. Because you're not wasting any power on 9 times 7. Oh my God, 9 times 7. Right? Of course, you know that it's 63. Thanks, jump math. You know that trick, right? You didn't use good. How many of you use that trick for your 9 times table? Yes, you do. How many of you? Yes, you do. You use that stupid trick. 9 times 7. So you go 9, 8, 7, 6. I can't even remember how it works. It's such a stupid trick. Oh, no. You go 1, 2, 3, 4, 5, 6, 7. You fold down the finger, and then it's 1, 2, 3, 4, 5, 63. I'm serious, Megan. There are teachers teaching that trick because people have said that memorizing things is bad. You shouldn't memorize things. That's not good practice. Because memorizing stuff isn't what you're being tested on. That's not learning a concept. But try it with anything. What's 9 times 3? 1, 2, 3, right? 22, 7. 27. There's another one where they count on their knuckles, but I don't know that one. You know why? Because I memorized the times tables and it worked just fine. I want this recording because I want the world to know how silly it is to have stopped making you guys memorize stuff. For some strange reason, memorizing has become evil. Okay, next. Okay, guys. This one should be the easiest. But for some reason, people have trouble with it. We'll start with a nice simple one. First of all, let's analyze the name of it. Difference of squares. What does difference mean? Subtraction. So you can only do this kind of factoring if there's subtraction. What does it mean if something is a square? I liked it better when you two just punched each other. What does it mean when it's a square? It has a square root, right, Burke? So, if I gave you this, x squared minus 16, you could factor it, yes? What would it be? X plus 4, x minus 4, yes? Because it is always the square root of the first one and the square root of the second one, with a plus c minus in between it. Why? Because just like multiplying by the conjugate, I need to make the middle term drop out. And when I multiply this out, I would end up with negative 4x and positive 4x, so it drops out, yes? Now everybody tells me they understand this concept just fine. And then I do something like this. X squared, 4x squared minus 64y squared. And then all of a sudden they're in trouble. What's that? 2x minus 8y, and then the same thing, but with addition. Yes? Then I give them this one. And then they tell me they can't do that. What's that one? Two xy plus 8ab, and then the same thing. Everyone's still okay, yes? Okay. Then I give them this one. What's that? Now the wheels are starting to get a little wobbly, right? They haven't fallen off yet. Don't all rush to give me an answer. X squared minus 16 x squared plus 16. Is it done? Of course not. Why, Sukpal? Because there's still a square there. X plus 4, x minus 4, x squared plus 16. Is everybody good there? Like I said, the wheels are starting to get a little wobbly now, yeah? What if I give you this one? Now what? I'm actually going to slide this one up here. Son of a motherless goat. Okay, what's that one? Everybody who's been in my class in grade 10 has been given a wonderful strategy to solve problems like that, if you remember it. I'll give you a big hint. Look at that question and look at that question. And tell me if they look similar. No. Do those two things highlighted in blue look similar? Yes or no? This is a yes or no question, not a math question. Do they look similar? Is it something squared minus 16? Is this something squared minus 16? Okay. What if I wrote this like this? A squared minus 16. What would the answer be? A minus 4 and A plus 4, yes? Are there any A's here? No, but there's an X minus 7. So what should I write there instead of A? X minus 7 minus 4, which is what? It's not a trick question. X minus 11. X minus 7 minus 4. And what would you write here? X minus 7 plus 4. And what would you get for an answer? X minus 11 and X minus 3. Is everybody good? So finally, let's take that to its logical conclusion. You have all the building blocks right there to solve the hardest difference of square question I can give you. And we're going to be stopping there anyway. That's your homework.